Hello, my name is Andrew Young, and I teach physics here at Casper College. We are a small local community college located in Casper, Wyoming. I have been teaching here since 2005. Our physics department offers a variety of physics courses tailor-made for a specific population. We offer conceptual physics for elementary education majors. We offer algebra-based physics for life science majors. And we offer calculus-based physics for engineers and natural science majors. In teaching these different subject classes, we found it necessary to implement a variety of different remote lab techniques in order to address their particular needs.
For the conceptual physics course, I utilized a video game simulation called At Play in the Cosmos, the Video Game by W.W. Norton. In this program, students learn about various topics in physics and its application in an astronomical context. They are to pilot their ship and activate several diagnostic tools in their exploration of objects and phenomena in the universe. To help facilitate this process, I employed the cultural zeitgeist of Twitch streaming programs. What you see here is an example of some of my playthroughs. I ran through all 20 video game simulations and video recorded my entire playthrough. I then uploaded my video files onto Google Drive for students to access as a resource. For the algebra-based physics course, I created a series of what I call converted live labs. In an effort to replicate our traditional live lab environment, I used the standard live labs as a physics template. I prepared and conducted each of the labs on my own and recorded videos and took photographs of experiments in progress. I uploaded these videos and photos into our learning management system. The students would then analyze the photos and videos to extract information and data from these experiments. A final report would be turned in that had the result of their analysis. I later migrated away from this method in favor of boxed lab kits. For the calculus-based physics course, I turned to the method of boxed kits. My students purchased a self-contained kit from a commercial science company. They would conduct the experiments at home using the contents from the box with some consumables on their end. Upon completing the experiments, they could either turn in an Excel sheet with all of their results or submit their answers into the company's cloud server. However, I want to supplement this process with my own method and how I approach the labs. Thus, I created my own series of videos where I meticulously went through all of the labs, laid out the required tools, and worked out the experiments. I did this to convey my expectations for student success and to show them my process for successfully completing a lab. I uploaded these videos into our learning management system where the students can review the videos at their leisure.
In summary, each course archetype requires its own unique solution. Creating and implementing a robust online laboratory experience requires a multitude of tools consisting of software, boxed kits, and instructor-generated material. When all these assets work together synchronously, we can deliver a comprehensive, robust educational package. It is my hope that by employing these different lab techniques, that we can best emulate and translate the live lab experience into the new digital remote learning environment, and that the combination of commercial products and instructor-generated material can help facilitate the interface between physics concepts and physics applications. We have now come to the end of this video. Thank you for your time.